full 5-axis alignment on a part on the Grob. So the first thing we're going to do is go to the swivel, and we're going to swivel up to roughly the angle we think it is. So set that up. And the next thing we'll do is get our probe in the spindle. That's real easy. Loading the probe. And then we jog out. To roughly the middle of the part. And then we'll go on either side of the middle, and we will go to measure workpiece, and we'll choose any cycle, and then from there we'll go down to align plane, work offset 507 seems like a good one, and cycle start. We'll take a point there, and then we'll move away in X. We'll take another point there, and then we'll move back in X and up in Y a little bit. Just 3 points, sort of as far apart on the plane as we can get them. And we'll take the probe out of the work area, and we have our 3 points saved. So we hit set work offset. We can see it set some numbers. We're going to activate that offset now. And then it asks us if we want to set the probe perpendicular through swiveling, and we're going to say no. We're going to back out of that. So now we are going to bring our probe back out, and we're going to come up, and we're going to align an edge. So we're going to come down here. We're going to choose our align edge, and we're still going to do 507. We're going to rotate the coordinates to fit this edge, and we're going to take a point at a couple of spots on top of that part, and we'll move away a little bit, take another point. And so now we're back over here, and we're going to say set work offset. So let's put that rotation in the work offset. Now we're going to choose. So now we've got our 3 points to establish a plane. We've got our 2 points to establish a line. Now we're going to pick up our point, and our point is going to be a rectangular spigot. And so we're roughly in the center of that piece of material, and we are going to go just like this. We're going to cycle start that. Turn the probe on, it'll come down and grab both ends. And then it'll come back, and it'll grab the center, top and bottom. So there it is. Now, we have a position for that. The problem is that it's not a point, it's a line. We found the center, but that line runs the entire length of the spindle center line for infinity in both directions. So we have to give it a value, and that would be a Z point. So we're going to go to a different cycle now, and it's going to be go back here, and we're gonna go single Z point. We're still gonna set 507, and we're gonna put it 20 thousandths below the surface of the material. So whatever we check is gonna be a Z plus 20. And we cycle start that. And now we have defined it. And if we look at these numbers here, and if you rewind the video just slightly, those numbers were nowhere near that large when we found the center of the material. And that's because that line was projecting through the center of rotation. And where the line going through the center of rotation for the B plane, or for the B rotary, and the line through the center of the spindle at that center point, where those intersected was where it set the 0 point until we gave it a Z location on the surface of that material. So now we're all set. If we go to offset and we go to 507, we've got a position roughly 8 inches off the table, 6 inches toward the spindle from center, and 13 thousandths off of center in X. And then we've got these rotations around those different axes to correct for the angle of the surface and the angle of the edge. So that is full 5-axis alignment, and we now know exactly where that point, 20 thousandths below the surface of that material in the geometric center, is at.